Okay, welcome to day 2. This is where we left off last time about inverse functions. If you remember, f of -1, this means the inverse of f, and each inverse will be the set of y's and x's such that, this is read such that the x and y belong to the original function f. Okay, so we're going to dig a little bit deeper into what makes an inverse function and why do we need these and how are we going to use them. So, we're beginning. I'm on page 259. There's a wonderful green box on page 259. That is nice and handy. I'm going to write some of them. If you haven't gotten your book yet, I'm going to write these out. But this is something that needs to go in your notes because some of this for this lesson will be fill in the blank type questions with things like definitions. Okay? The first one in the green box is summary of inverse functions. I'm going to go ahead and make a title. The summary of inverse functions. Summary of inverse functions. Number 1 says, in a one-to-one function. Now I wish I had something that would just write for me as I talked. I don't have that. Maybe someday. In a one-to-one function, each x value corresponds to only one y value. Okay, that's the function, right? Each x value corresponds to only one y value, and we put that and in there, and each y value corresponds to only one x value. That makes a one-to-one function. Okay? The second one, I'm going to change colors. I need to change a pace here. If a function f is one-to-one, then f has an inverse that we will write as f -1. Okay? Number 3. Now I'm going to change colors every time. The domain. Do you remember the domain? What is the domain again? That's right, all the inputs, all the x's. The domain of f, so the input of f, is the range. What was the range again? That's right, the output or the y's. So I'm going to go over here and put the x's. The range is the y's or the outputs. Is the range of f -1 of the inverse. So the domain of f is the range of the inverse. And the range of f is the domain of the inverse. That's quite a handy thing to have. Okay, now I have to come up with other colors that I haven't used. We're going to use some different things, and I'm going to scroll down. Okay, you can go ahead and start reading number 4, which is the graph. Ooh, I hope you can see that. I bet it's prettier on your computer. The graphs of f and f -1. So the original function and its inverse are reflections of each other, but it's across the line. Y equals X. So we'll talk about that in just a minute. Recalling what is that line. Okay. And the last one, last but certainly not least, number 5. To find the inverse. To find f negative 1 from f of x. Okay, we're going to follow the steps. We all like steps, right? You do this, then you do this, then you do this. So I'm going to put a little step 1. Okay, step 1, we will replace, if there's an f of x, we're going to put a y. Okay, we're going to replace the f of x with a y and interchange, you can switch them, interchange the x and the y. Means wherever you see y, you're going to put the x, and wherever you see the x, you're going to put the y. Okay? Step 2, you're going to solve for y. So you want y by itself, so you will solve y equals. Okay? Our step 3, we will simply replace the y with the inverse symbol. That will be the inverse function. Okay? So now let's work through some problems. I'll give you just a moment. You can pause it actually, so I'm probably not. We can go on. So if I give you a function, I'm going to start out pretty nice. I'm just going to start out with a line, but I'm going to start with f of x. So here's our first example. Okay, so if f of x equals, I'm going to say 2x minus 5. Okay, that's the f of x we're given, and we want to find the inverse of it. That's our goal. Okay, so what was step 1 again? Yeah, we're going to change the f of x to a y. Y equals 2x minus 5. Okay, that was the first part of step 1. The second part of step 1 is we're going to switch the x's and the y's. So I'm going to put here interchange, if I can spell it, x and y. Means I'm switching. Where I see an x, I'm going to put a y. Where I see a y, I'm going to put an x. Okay, then I'm going to solve for y. Oh, I've got to get y by itself. So what should I do? I'm going to add 5 to both sides. All right? So I have x plus 5 equals 2y, because those 5's are going to cancel. Okay? Is my y by itself? Not yet. I still need to divide by 2. Okay? Now, I personally like the y on the left side. It doesn't really matter, but I'm going to switch. I'm going to say y equals. Now, you can leave it as x plus 5 over 2. Or, it can be written as x over 2 plus 5 over 2. Now, that would have been nicer if the 5 were divisible by 2, because that would have just been a number. It's okay, it doesn't matter. Okay? Next step. Wait, what's that last and third step? We're going to replace the y with f negative 1 of x. So the inverse of this function is x plus 5 over 2. See, I wrote it one way. It's okay. So, we followed all the steps. So my y step was replace the y with f negative 1. Okay, we followed all three steps. We've solved. We have an equation for the inverse. I would like to look at this graph, both graphs. So make sure that you have that written down. I need to make sure that I have it written down. All right, and it's helpful if you have the minus and the pluses where they're supposed to be. Okay, so I'm going to go ahead and do a graph, and I'm going to graph each equation and see, does it look like, oh, I don't know if you can see that black line. We're going to undo it and do it a different color. I'm going to make it blue. That way it pops a little bit more. Up and down. Here we go. And another piece talks about the graph. Looking back at number 4, it says the graphs of the function f and its inverse, f negative 1, are reflections of each other across the line y equals x. Keep that in your brain, and we're going to see what is that line. Okay? Our original equation was f of x equals 2x minus 5. I'm going to graph that in red. Our inverse function was x plus 5 over 2. Okay, I'm going to graph that one in green. So, graphing the original function, f of x equals 2x minus 5. I'm going down to my y-intercept. It's 1, 2, 4, 5, starting at negative 5. And I'm going up 2 and over 1. Up 2 and over 1, 2 and over 1. I can keep going as long as I have a spot. I can go back down 2 and left. And we're going to see how close I can get to drawing a straight line when nobody is here. So that is my f of x equation. Okay? What about the inverse function? X plus 5 over 2. I might rewrite that. You remember how I rewrote it as the x over 2 plus 5 over 2. Okay? Maybe you see the slope and y-intercept. If you don't, you can pull the over 2. It's 1/2 x. So my slope is 1/2. My y-intercept, if it bothers you that it's 5 over 2, we can say that's really 2 1/2. Okay? So all of these equations are the exact same equations. The last one's a little easier to see, to graph. So my y-intercept is a positive 2 1/2. Okay? My slope is 1/2. So I'm going to go up 1 and over 2. See, I had to go to that half mark. Up 1 and over 2. Up 1 and over 2. Up 1 and over 2. Okay? I can keep going. Up 1 and over 2. Could I go down 1 and back 2? Yes, Miss Evans, you could. Down 1 and back 2. I could keep going. I think I'm ready to stop. Oh, because I'm getting a little off on drawing that line. Okay, this is the graph of the inverse. Okay, are they perpendicular to each other? No, they're not. Not at all. But they are related because they are reflections about the y equals x line. I'm going to draw this in black now. So y equals x, before I go on, the line y equals x. I'm going to draw in black. What is the slope? What number is before x? It's a 1. X plus, what's plus what? Nothing. There's a 0. What is your y-intercept? 0. Okay, what's my slope? I'm going up 1 and over 1, up 1 and over 1, up 1. Oh, look at there where they meet, where their inputs and outputs are the same. Up 1, over 1. Can I keep going backwards? Down 1 and back 1, down and back. I can. I can keep it going forever. Lines go on forever. This is the line y equals x. So if I could just fold my paper, you can fold your paper. If I fold my paper on this black line right here, okay, I can't go over it again and make it straight. Sorry. If I fold it, will the green line and the red line be right on top of each other? Yes, they will. Okay, that is a graph example. I've shown you how to find the equation. We're going to do some more tomorrow because I'm pretty sure I have hit my time limit. I will see you guys tomorrow.